Okay, so let's start working through this. So if I want to define f prime of x, the first part I'm going to need is this f of x plus h. So that means everywhere I used to have an x, I need to put in the x plus h. So x plus h squared, quantity squared, minus 2 times x plus h. That's the piece that goes into the first part of my difference equation. If you want to clean this up first before you start putting it in the big long fraction, that's fine. So I'm going to clean that up as I write it down. So I'm going to FOIL this out. So x squared plus 2xh plus h squared. I'm going to distribute. Make sure the negative sign gets distributed. Minus x squared minus 2x. So this is f of x plus h, and this is f of x. Okay, so those are my two pieces, all divided by h, and I forgot my limit in the front. Okay, so the x squareds cancel, and the 2x is canceled. You should expect basically everything that does not have an h in it is going to cancel. That's kind of a fair, for polynomials, that's fair. So then I'm going to have limit as h approaches 0 of 2xh plus h squared minus 2h all over h. Every single piece has an h, so I can be fair and take it from everybody. Or if you want to, factor an h out of the top, and then you have multiplied factors that cancel. Just remember, you cannot cancel just those two. Okay? So this would give me limit as h approaches 0 of 2x plus h minus 2. Did I do that right? I think so. So now I'm ready to plug in h. I don't have anything to plug in for x. Is that okay? Yes, you just keep writing it down. So everywhere there's an h, I put a 0. So I'm going to finally get 2x minus 2. So that's the equation, the formula for my slope at any point on this curve. So the point of interest is x equals 1. So I can write f prime of 1. That says what is the derivative of the function at x equals 1. And we do get 0. So we know that this is the slope. That means you know you have a horizontal line. So because you have a horizontal line, we could just write the y value, right? Horizontal line will just be y equals, what is y equal to? Put in x equals 1 here, I get 1 minus 2, negative 1. So this is the equation, and this, I guess here is my slope. The important part with this is taking care of the algebraic manipulations in here. Once you get that right, the rest of it sort of falls out. So, secant line, does secant line use limits?
No.
No. Secant line is algebra. It's all about 2 points. It's the 2-point slope you've been doing forever and ever and always. So secant line does not use limit. If I say find the instantaneous slope, is that 2 points or 1 point? 1 point, so that's derivative. Okay, so remember we have two camps. We have algebra and we have calculus. 2 points, 1 point. Average, instantaneous, secant, tangent. Okay, so if you can keep those, but they're all about slope. They're all about rate of change. Okay, so one last bit that I need to talk about is differentiability. This is not something I'm going to make a big deal about. But just like we can tell what's continuous and what's not, we can tell what's differentiable and what's not. So let's just talk about that briefly. Okay, so differentiability. You might imagine that just like domains are not necessarily all reals, that a function might not be differentiable everywhere also. So differentiability requires the following. First, the function has to be continuous. Well, now we know what that means. So it has to be continuous. So that means you cannot, spell right, a function cannot, does not have a derivative at a gap, a hole, a jump. So continuous plus. I'm going to write this. derivative must be finite. Slope is a number, right? So if it's vertical, I can't write that. Okay, so I need to have a finite derivative, a number, and the function has to be continuous. So what does that exclude? Remember, for continuity, we said no gaps and jumps. So this means that same thing: no gaps, jumps, vertical asymptotes. That list is all still good because that's the continuous list. What is this derivative must be finite part? What does that add? Let me give you a couple of examples. One is this one. Continuous there, right? I didn't pick up my pen, but is there a derivative here? No, because from one side it's positive and from the other side it's negative. And remember, it's based on a limit. So I wouldn't know which one. So this one is not differentiable. Another one that is not is this one. I've kind of drawn it in an exaggerated fashion. The slope becomes vertical at that point. How do I write that? I don't have a number I can write down. So just remember that differentiability means the derivative, the slope exists and makes sense. So continuity issues are an issue, but then also these other two pieces. This is called a cusp, and this is just simply a vertical slope. So in both of these cases, the derivative does not exist. So you've got some problems for that on homework, but this is not a huge thing for me, because the functions we're dealing with in this class are all differential. Okay. Time. So, shall we do a word problem? Sure. Because you guys love word problems. Okay, so this will be we're not doing word problems in these sections, because we're going to wait, and rather than doing them the hard way, I'm going to wait and hold the word problems for derivatives until we have the easier way to do it, so that way you're not cranking through lots of this for no reason. All right, so let's go back then and look. Let's look at one from. Is there one from homework? Did anybody? Not a piecewise one, but is there one from homework? Did anyone remember for difficult average cost median what it approaches? Look at that one. No. All right. So let's do this one. This is on page 119, number 85. Okay, so a company manufacturing snowboards has fixed costs per day of $200. So I'm going to read it through. So let's talk about how we solve word problems. Read through the whole thing first. The thing you're looking for first is you want to be able to write this. You're looking for what you're trying to find. You need to know that first, because that's going to drive how you solve the problem. All right, it's kind of like your key word. So it says a company manufacturing snowboards has fixed cost of $200 per day, total cost of $3,800 per day for 20 boards. Assuming the total cost is linearly related to the output, what's manufactured, write an equation for the cost function. So the first thing I know is I'm trying to find an equation for C of x, and it's linearly related, so what do I know the form will take? mx plus b. This is what I'm trying to find. Or you can write equation of a line, you can write however you want to do this, but this is what I'm aiming for. So if I'm trying to find the equation of a line, now that says what I need to go back to my problem and see what information I have and write it down in a way that makes sense to find this. To find the equation of a line, what do I need? Point and a slope. Or 2 points. Okay, so let's look at what we have. We had fixed cost of $200. And you can write this, fixed cost equals 200. That's still a lot of words, so that's not math yet. If I wanted to translate this in, knowing I'm looking for 2 points or a point and a slope, what would I call, how could I write this?
It's per one board, so...
This is, no, fixed cost means just
okay, so zero,
for zero boards. So I could write 0, 200. What else do I know this is?
Y.
It is the y-intercept, right? Because if x is 0, so I actually know that b is 200. I already know b. So if you see this, great. If you don't, you just have a point. That's fine. All right, so now what else do I know? I know that I have $3,800 for 20 boards. Still a lot of English. How can I translate this into a very succinct math fact?
20.
X is 20, Y is 3,800. Now, remembering that I'm looking for the equation of a line, 2 points, I'm ready to go. And this is, so if you can write it down this way, then this helps sort of drive the next step, because what's the next step? I need to find slope. So you need to find slope. But this is, having written them in terms of points, I'm going to get the slope right. So 3,800 minus 200 over 20 minus 0. Some of you on the assignment got 190 because you didn't do the minus 200 part. So if you write it down as 2 points, then you have a better chance of seeing, getting it right. So I'm going to have 3,600 divided by 20, 180. So now, if I have recognized that this is the y-intercept, I have the y-intercept, I have the slope, I have the whole thing. So my final answer, the cost function is 180 x plus 200. We need to, so this is an important thing. Please note that I do have, like I said, the clarifications file. And so how I'm titling that is sort of in bold blue is the section assignment that it comes from. So that way you can kind of quickly see what you've already read and keep going. One of the things that's important is there's a big difference between identify and interpret. If I say identify the slope in the y-intercept, I say slope is 180, y-intercept is 200. That's identifying. That is not interpret. Interpret says put some meaning to it. Use some English words, some sentences, and write a meaning. So what is the meaning of m equals 180?
Each board costs $180.
Yes, each board is, so some people call that the variable cost, the per item cost. So m equals 180, that's the identification. The interpretation is variable cost is $180 per board. Identification of the y-intercept b equals 200. Again, that's just identifying it. Interpretation is, what's the interpretation of that? If I make no boards at all, I still have, so it's kind of like your setup costs or just fixed costs. They're just costs that you have no matter how many boards you make. So this says that, maybe we'll call it setup cost or fixed cost, either one is 200. Please remember dollar signs and year units, because a word problem is going to have word answers, so you need to include that for context. Okay, average cost. You remember how to do average cost. So I'm just going to take this whole thing. Average cost, we call this, with a bar over the top. For those of you who've taken stats, you know what the bar means. And so this is just going to be 180x plus 200 all over x. The important difference is this is a per board cost. Average cost is different. Per board cost says you've added, for every board additionally you make, you add another $180 of cost. Average cost is different. It says you have made this many boards. What's the average? And it includes some of that fixed cost. So average is different than per board cost. Okay, so I can find the average at, pick anything you want, right? You can find that. What is this tending toward? Well, I could write this another way. I could write it 180 plus 200 over x. As x gets really big, maybe even think about it heading off to infinity, even though we know we're not going to make that many boards. As this gets really big, this is going to go to nothing, right? That's going to become inconsequential. And 180 is going to really be what your average board cost is, as the number gets really large. So this is as x gets large.